Hello. This lesson is going to be on graphing cotangent, cosecant, and secant functions. Now, cosecant and secant graphs are very different. So we're going to talk about its reciprocal graph, which is sine. So here are just some numbers that we've done before for sine. And remember, we know that cosecant is a reciprocal of sine. So instead of looking at the unit circle like we did, we can just take the sine values and then do the reciprocal. So the reciprocal of 0 is 1 over 0, which is what? Can you divide by 0? No, so this is going to be undefined. I'm just going to write U and D. This is going to be 2. This is going to be 1, 2. This is 0, so that's also going to be undefined. Okay. And then here's going to be negative half, negative 1, negative 2. The reciprocal of negative half is negative 2. And then here's going to be undefined. So we can see a pattern. Anytime where it is 0 for sine, it's undefined for cosecant. Anytime it's 1 or negative 1, they're going to stay the same. So the easiest way to do a cosecant graph is first to actually draw the sine. Okay, so I'm going to graph this first. Just a normal parent graph that we're used to. So it's 1, 2, negative 1, negative 2. So here, up, down, middle, down, middle, up, down. Okay, so here's our graph. So anytime it's 0, we saw that in here it's going to be undefined. So anytime it's 0, it's undefined, which means, yes, you named it, asymptote. Right? And anytime it was 1, okay, that's the highest point here, it's the same, right? Or sorry, here. And then when it was negative 1, it was the same. Okay. So where the peaks are and the valleys are for the sine, that's where the points are also for cosecant. But it said at pi over 6, which is about here, right? It's 2, so it's actually up here. And 5 pi over 6 is up here. So what happens, it looks like a nice U. Now you have to make sure that it stays between the asymptotes. So what about over here? Well, at 7 pi over 6, which is about here, it's going to be 2 again, or negative 2. 11 pi over 6, which is over here, it's going to be negative 2. So again, you have another U-ishy shape. So every time here in our valley, it's going to go a downward U. And up a peak for a sine, it is an upward U. So the peaks for the sine graph becomes the minimum of the cosecant for these parts. Okay? And then for here, where the values are, that becomes maximum points for these cute little U's. All right, so this is a little bit more complicated, right? So let us look. Let's look at our domain. So our domain, you can see that it is everywhere in between your asymptotes, right? So it's all real numbers. And I'm going to write this in set notation. So x is an element of all real numbers except. Now, where is that? So I can see, I'm going to talk about asymptotes. Might as well talk about that there. So my asymptotes, I can see it's 2 pi, pi, 0, pi, 2 pi. So clearly you can see there's pi's, and here there's probably pi, but they multiplied it by 0. So it's truly a pi. It's x equals. So what are the numbers in front? Right? What changes? So it looks like -2, -1, 0, 1, 2. What are those numbers? Those are integers. So k pi, where k is an element of integers. Oops, sorry, I put real numbers. I said integers. My hand wanted to do something else. Sorry. It is that nice Z. So here is where the asymptotes are here. So we're going to say all real numbers except where k is not k pi, where k is element of integers. Now range is a little different as well. Range is different because you can see this is here and up, but there, here it's below. So in this middle part and here, there's no range. Remember, the black part is sine and not cosecant. So the range, it looks like it is from this part down. So it is y is less than or equal to -1. And it also y is greater than or equal to 1. So that's 2. So let's look at x-intercepts. Do I have x-intercepts? No, I don't. So that's none. Do I have any y-intercepts? Nope, that's none. Is it symmetrical? It is odd, to go with the sign. So we're going to talk about the vertical stretch. So it's going to be that A that's in front here, which is 1, and our period, like sine, is also 2 pi. So when we're talking about one full period, for cosecant, it's here. So that's one full cycle, one period. So it must include one up and one down with the asymptotes. So definitely a very different graph than sine. All right, so how do we actually graph them? Well, we actually do the sine first. So what I do every time, I take this graph, this function, and I'll rewrite it in sine. And graph that first. But let's talk about the vertical stretch. So it doesn't have an amplitude because there's no highest or lowest point. But I know it's going to just stretch at 1. My period is still 2 pi. There is no horizontal shift, and the vertical shift is -3. So I'm not going to graph the parent graph. I'm going to go straight to this. So I know we've dropped our midline 3. And then the sine would stay the same. So again, I'm doing the sine first. High, middle, low. Okay. All right, so remember, wherever, for now we're going to graph the cosecant, and I'm going to graph the asymptotes. So And do the asymptotes. Remember, it's where for the sine it would have been at the x axis or x-intercept. So over here, this is our new midline. So it's wherever point for that sine is on that midline. You're going to draw in the asymptotes. Yes, draw the asymptotes. Part of the reason why I know you did it by hand. Then you take your peak. You're going to draw a nice U. And your valley, you can draw a view in the other direction. Yeah. And then here you are. So I have 2 cycles, and this is going to be g of x. This over here is f of x. So again, draw the sine. It's the easiest way to do that to get the most accurate graph, right? That is what we're looking for, accuracy. All right, so another cosecant graph. So I'm going to look at that. So I have a vertical stretch. So what's the A? So the A is 3. My period. So here's my B. So just like sine, it is 2 pi divided by 2. So my period is pi. My horizontal shift is none, and the vertical shift is none. So I'm going to graph. I'm going to rewrite the function as sine. And this. All right, so I'm going to go from one period, so it's going from 0, right, to pi. That's what your period tells you. One cycle, one up, one down is going to go from here to there. And then the midpoint is here. And then we're stretching up there. And we're stretching there. Okay. So you can see that there are more cycles in this. Oops. Okay, there we go. So again, this is the sine. This is g of x. Okay. So you can see that the vertical stretch now really shows more in the sine how it stretches. So at the x-intercept, so I didn't draw vertical. Okay. I know, it's more than one cycle. It's more than 2. All right, and now we're going to, I'm getting a different color, orange. Okay, at the peak, yeah, here, valley, peak, valley, stay inside the asymptotes. This is why we draw them as a guide. Okay. F of x. Right, another level. It's really cool. I know there's more steps, but I think they're just so cool. Look at that. All right, let's go to secant. Now secant, guess what? It's related to cosine because it's also the reciprocal. So let's find the point. So we're just doing the reciprocal. Undefined. Doing the reciprocal, undefined. Okay. So guess what we're going to graph first? Right, we're going to graph cosine. Okay, so remember cosine starts up And we're going to finish there in one full period, second period. Okay. So I'm going to take where it's undefined. So let's look. So it's the same like cosecant, where the cosine is 0. Secant is undefined. So that is going to be at the x-intercept for this paragraph. And here. So now here, because your x-intercept is right here in the middle on the y-axis, so this up, right, is going to be straddle halfway on one right of the y-axis and to the left of the y-axis. Just like the other ones, yes, you're going to draw nice U's. So I'm only going to draw half. So this is up here, it's just 1.5 cycles. So yes, you have to draw that one. So then you have your 2 full cycles. All right, so domain. Again, domain's a little different. I'm going to do the asymptotes first. So where are the asymptotes? So the asymptotes are -3, pi over 2, pi over 2. Doesn't sound familiar. So what's in common? So I have pi over 2 in common. And then what's changing? All right, so we can write this a couple different ways, and we've done this before. So we can say that k is odd integers, right? We've talked about that before. So this is odd integers. So, or we can write it like this. K pi, plus k pi, there you go. Where k is a set of integers. So this will get me that odd. So for domain then, x is all real numbers except where the asymptotes are, which is pi over 2 plus k pi. The range is just like cosecant. Y is less than or equal to -1, and y is greater than or equal to 1 because it has that gap, right? It's here and up, so it equals 1, and then it jumps and has a gap. All right, vertical stretch is 1, period is 2 pi. All right, are there any x-intercepts? No, none, because they're not here. So you can see no orange part. No, there's not an orange point on the x-axis. Done. Y-intercept is right here. That's going to be 0, 1. Symmetry is even. You can fold it along y because you can see that it folds nicely across. All right, so let's look at this one. Okay, so I have a vertical stretch, just 1. Period, still 2 pi. Horizontal shift is -pi/4 to the left, and the vertical shift is up 2. All right, so guess what we're going to do first? That's right, I am going to graph the cosine. Okay. Now, usually I would have done the paragraph of cosine to do the horizontal shift. I'm just going to go straight to it. So usually the cosine would have been here, right? but we're moving it 1 to the left. So it's going to look like this. Every 2 lines, since I didn't change the period, it's going to be a point. This one's going to go here. Oh, darn it. You're right. I forgot. Up 2. Darn, darn, darn. So what happens when I don't draw my midline first? I'm glad I caught myself. It happens to all of us. Okay, so what am I doing? I am putting all the points up above. Just gonna move them. Darn. Sorry about that. I can hear someone say, "That's what I thought." Good. Glad. Go with your gut. Okay, there we go. So shift it over. Okay. Really make sure these middle points are on your midline. See, this one's not. So try to sketch that better. There we go. All right, so asymptotes. The asymptotes go where that midline is. Okay. Right, valley is going to go this way. Peak, valley, down, goes up. And there we go. F of x. Lean back and admire your work. So nice. All right, so let's do another secant. So this one is a little bit different. So I see I have a vertical stretch of 2. I have a period of, ooh, that's different. Okay, so my b is now pi. So to find the period, it's 2 pi over pi, which is 2. So there's no pi. All right, so sorry, it looks like it's like a negative. It's not. Vertical stretch is not a negative, but there is a reflection. Okay, so horizontal shift is 0 and the vertical shift is 0. Okay, I'm going to circle that so I remember that. I'm going to do this. A moment. Okay. So we're going to stretch and then reflect. Okay, so if it's 2, how do we label our x-axis? Well, you just, okay, so because it's 2, it's very squished, and I need some space. So, because if I put 1, 2 here, ooh, that's going to be very, very tiny and tight. So what I'm going to do, I'm going to go every other one. So I think I'm going to do 1 here and 2 here. Okay. So this is going to be -1, -2, -3, skipping every other one. Go. Now for cosine, for here, it usually would be at 1, but now we're going to go an amplitude, a vertical stretch of 2, and then we're going to flip it, right, for the reflection, so it would be here. Now it's going to go to a period of 2, so this is where the 1 cycle is going to end. Begin here and end here. So at 1, which is halfway, it'll be there. Okay. And there we go. I'm going to do just 1 more cycle, I think. There we go. Okay. So it looks like this. Oops. Okay, I'm just double checking, flipped it, stretched it. Okay, and then it's 5. So do you see the x-axis just changed numbers? That's all. But it's still remembering that from one cycle, beginning to end, halfway is the midpoint for your cosine. All right, so I'm going to put in some asymptotes, and now we're going to graph secant. Oops. Darn, I'm not paying attention. That's twice. And no, I don't want to do videos again. I don't want to start again. I know you're like, Miss Mendoza. Sorry, not paying attention. Okay, it should go through the x-axis. There we go. It's like, why? It's not working. You're like, ooh, it's very tiny. Yep. Let me erase this a little bit better. Just get that out. Not confuse us. Okay. All right. Now at the peaks, there you go. In the valleys. So much more narrow. F of x. All right. Still looks good. 2.5 cycles. All right. Yes, there's one more. Cotangent. So cotangent, it's related to tangent. So wherever tangent is, remember it's the reciprocal of it. So anytime it is undefined, it's going to be 0. And then reciprocal of -1 is -1. And with 0, it's going to be undefined. And then this is going to be 1. And this is going to be 0, -1, undefined, 1, 0, -1, undefined, 1, and 0. Remember, I am just doing the reciprocal. Now for this one, I'm not going to draw a tangent. I'm going to go straight to cotangent. So I can see that my asymptotes, right, is here. So it's at pi, it's at 0, it's at, sorry, -pi and then pi. So it would probably be 2 pi the next one and 2 pi. So if you look between your asymptotes, I'm going to say without looking at the table, pi over 2 should be 0. So let's look. Pi over 2 is 0, right? And then -pi over 2, and then 3 pi over 2. So you can see halfway point, just like tangent, is right in the middle, right? At the x-intercepts. Now let's look at pi over 4. Pi over 4 is pi over 4 is pi over 4 is 1. Sorry. And then 3 pi over 4 is -1. Ooh, well, that's different. And pi over 5 is here, and then 1. Okay. So now it's 1 here and there. Okay. So cotangent looks like this. Similar to tangent, but the other way. So let's remember, tangent, the graph looks like this way. And the y-axis is right through the center. So slightly different. So you can see that this is right through the center of the y-axis is actually an asymptote. So different. So it's moved over. It's not straddling the y-axis this time. And now it is up and then down, as opposed to tangent, where it's down and then up. It looks almost, well, it actually looks like a negative tangent shifted, with a horizontal shift. All right, so let's talk about the domain. Okay, so clearly I have asymptotes. And where are my asymptotes? My asymptotes are -2 pi, -pi, 0, pi. Okay, so this, we've done this one earlier today and before. It's just like cosecant. So x equals k pi, where k is integers. So the domain is all real numbers, except where x equals k pi, where k is element of integers. The range is all real numbers. Vertical stretch. So this is the A. So no, this doesn't have an amplitude, just like secant and cosecant doesn't have an amplitude because they have no lowest point or highest point. This is 1. It's still the A that's going to be in front of here. My period, and if you can see your 1 cycle here, it's from 0 to pi. So just like tangent, it is pi. The x-intercepts, okay, so the x-intercepts are going to be pi over 2 plus k pi, comma 0, and k is z. Okay, and the y-intercept is none. The symmetry is odd. Cotangent. All right, cotangent. So I have a stretch of 1, a period of pi, no horizontal shift, and vertical shift of -3. Now we are reflecting it. So it's usually like this. So now we're going to reflect it. It's going to look like that. Like, oh, so it's going to look like tangent. Yes. Yeah. So I'm going to drop it by 3. 1, 2, 3, 4. 1, 2, 3, 4. Midline is now here. Okay. Because I didn't shift it. And I didn't do a horizontal shift. The asymptote is still through here. Intercept and a pi and a 2 pi, negative pi, and -2 pi. Oh. So it's going to be here. And like we said, because of this is going to go from here to there. Sorry. I did that wrong, didn't I? Okay, now I can't remember what I said. Cotangent looks like this. But we're going to make it look like this, like tangent. Okay, so this is cotangent. We're going to make it like tangent because we flipped it. So if I said that wrong earlier, so sorry. Okay. I just told myself we were reflecting it, and I didn't do it. Okay, so it's looking like a tangent. But it is not a tangent because the asymptotes, as we know, are in the position of a cotangent. Okay. Oof. So lots of things to make sure of before we graph. All right, cotangent. Again, it looks like a tangent, but it is reflected. Also, the asymptotes are here. A tangent asymptote would have started at pi over 2. All right. Don't forget to do practice on your own. Look back at your notes. and answer the EQ. Thanks for watching, class. I know this one was a long one. All right, bye.